Okay, so let's review yesterday's lesson. So you should have learned that a systems of inequalities is when you graph two systems at a time on the same coordinate grid. So let's review. Here it's telling us, go ahead and graph these two inequalities on the coordinate grid below. So let's start by graphing this one right here. It's already in slope-intercept form, where my intercept is -4. So I'm going to go put a dot at -4 right there. And my slope is a +1/2. So that tells me to go up 1 and then right 2. And I'm going to do that until I can't fit any more dots. And I'm going to go in the opposite direction. I can also go down and left. And because it is a greater than sign without the equal sign at the bottom, this is going to be a dashed line. And if you recall, dashed lines means that those points on the line do not count as solutions. Greater means to go stand on your y-intercept and to make an arrow up, because that is going to tell you where you need to shade. So I'm going to go ahead and shade all of that. And this is why I tell you to do one inequality at a time. Okay, graph the line and then do the shading. Do not do both inequalities without the shading and then wait for the shading at the end. That's going to confuse you. So do each shading at a time. So there's that one. Then I go to the next inequality and I can see that it's just x and a number, which means it's a special line. It is a Vux. So I'm going to go to the x-axis. Here it is. I'm going to go look for the 2 right here. And I'm going to go ahead and make it a solid line. And it's a less than sign. So less, that means it wants to go to the left side. Okay, less is what your left hand makes. So then I'm going to go ahead and shade. There it is. So as you can see, there's blue area, there's a green area, and then there's like a yellowish area. This is the area that holds all your solutions, the double shaded area. And then it says go ahead and look at these ordered pairs and determine which ones are solutions, and go ahead and circle all the solutions. So let's go ahead and do that. 0, 0. That's right here. It does land on the double shaded area. So I'm going to go ahead and circle it. 2, -7. So 2 to the right, down, -7. That's not in the double shaded area. 0, -5. 0, -5. Not in the double shaded area. 4, -6. Not in the double shaded area. 3, 0. No. So it lands on the blue, which means it is a solution to the dashed line because it's on the blue part, but not to the other one. So then it won't be a solution to the system because it's got to be in the double shaded. 8, 0. -3, -9. -4, 2. This one is 1, -6. 9, -2. -4, -6. So look at this point. -4, -6 lands on the dashed line. And what do we say about points on dashed lines? They don't count. So even though is a solution for the Vux line, because it's on the green, it is not going to count for the dashed line because it's not solid. Okay? 0, 6. 5, -3. -8, -4. So that one is -8, -10, and 8, 8. So we only found 4 solutions to the system. What do we notice about where the solutions and non-solutions are found? Well, solutions are in the double shaded area. Non-solutions can be anywhere else. So they can be in the blue, the green, or the white part, and they're non-solutions. Is the point of intersection considered a solution? So they're asking about this point right here. Is it part of the solid box? Yes, it is. It's a solid line and all points on solid lines count. But do the points on dashes count? And no, they don't. So then it's no, because one of the inequalities is dashed. Okay, so that was yesterday's lesson. Along with problems where I already give you the graph of the inequality, the system of inequality, and you have to write the inequalities yourself. So first it says, using this right here, list 3 solutions to the system of inequalities. Well, I can see it. I don't know if you can see it clearly, but this right here is darker than any other area. So this is the double shaded area. So I'm going to pick 0, 0. I can go ahead and pick -2, 1. And I can pick -3 or -4, -3, just to show you that sometimes you can actually pick points on the line, because this one is solid, so it counts. And then for the dashed one, it was shaded below, so then it's also going to count. 3 non-solutions, I can get them from anywhere else. So I can say 0, -2. I can say 0, 2. Or I can say 4, 0. Is the point of intersection going to be considered a solution? So they're talking about this one right here. Well, because we've got the same scenario as we did in the back, for the solid it is, but for the dashed it isn't, then it's no.
Don't worry about it. You're not gonna believe this. See, I was just going over to